Jai Hind. I am Madhup Agrawal from AKGEC IT department. Today's our topic is Sieve of Eratosthenes. So, what is Sieve of Eratosthenes? This is a prime number generation technique. Sieve of Eratosthenes is an algorithm for finding all the prime number smaller than n. Means when we are going to find prime numbers up to n, then we can use the sieve of Eratosthenes. There are previous many algorithms which are used for generate the prime numbers, but the complexity for this sieve of Eratosthenes is much less than the other one. The complexity, time complexity is O n log of n. So this is much better than previous one. Okay. And this method was introduced by the Greek mathematician Eratosthenes in the 3rd century before the BC. And first we know what are the prime number and composite numbers. So as we know, prime numbers greater than 1 and the factors of a number if 1 and itself, then that are the prime numbers. So these are the property of prime number. Factor are 1 and the number itself, then a number is called the prime number. Just like we can say the 5 is greater than 1 and the factor of 5 is 1 and 5 itself only. So 5 is a prime number. Now the composite number. What is the composite number? The numbers that have more than 2 factors. More than 2 factors are called composite number. Sometimes we need this type of number also to generate the prime number. So here composite numbers. And the one property of the prime number is every prime number except the 2 is odd. Means every, just like 5 is an odd number. Only prime number which is even, that is 2, and all other even numbers are divisible by 2, so that they cannot be the prime number. So only the even prime number is 2, and other than 2 all the prime numbers are odd. This property are used many times to generate the prime numbers more effectively. Now the algorithms or steps how to generate the prime number using sieve of Eratosthenes. So the step number 1, generate numbers from 2 to n. First 2 to n, pick the number from 2 to n, and then traverse smallest prime number which is number 2. Just if we consider example, let 2, 3, 4, 5, 6, 7, 8, 9, 10. We want to generate prime numbers up to 10. So first step, generate prime number from 2 to n. 2 to n, generate the numbers from 2 to n and traverse from smallest prime number, that is 2. Means this indicate num is 2, this indicate num is 2, and the numbers are in this list 2 to n. And eliminate or mark all the multiples of number as 0 or -1, or we can say f, or other indication we can also use. So just marking the number or eliminate the number from the list. We can choose any approach, eliminate the number or mark the number. Marking, for marking purpose we can use 0, -1 or f, which are lesser than or equal to n. N means last limit. So in this example we first choose the number, that is 2. Eliminate or mark. So we can if we are going to eliminate the multiples of 2, that is 4, eliminate 6, eliminate 8, eliminate 10, eliminate. With the first approach, if we are going to eliminate, if we are marking, so there are number, we can mark this as 0, this as 0, this as 0, this as 0. If when we are using mark 0 as a mark value, If we choose -1 as a mark value, then we can use this one also, -1 here. If we choose f as a mark value, we can use f, 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 f here. So any approach we can take to mark the numbers. So, and then update the value of num to the immediate next prime number, as example. So we can choose the next prime number that is available, that is 3, and again update the value of num to the immediate next prime number. The next prime number is the next non-zero or -1 or f value, as in the previous example, in the list which are greater than the current number. So greater than the current number and not marked as 0 or some values. Repeat step 3 until number is less than equal to root of n. Here n is 10, so root of 10, that is we get something 3 point and something, so up to 3 we can choose only. This is the main basic funda to decrease the time complexity for this algorithm. We can see further why under root n we have chosen. So just now remove the multiples of 3 or mark the multiples of 3. So in this example 3, here only 9, so mark this is delete or mark as a, we can say here we can choose next number, but under root 10, that is only 3. So we stop here, and our list have only the prime numbers up to 10, that are 2, 3, 5, 7, only up to 10, means prime numbers up to 10 are 2, 3, 5 and 7. So we can see here. So repeat the step 3, we have already repeated, and now traverse the whole list and print the numbers as we have printed. All the numbers that are greater than 0 or greater than -1 or not the false value will be our required prime numbers lesser than n. This is a simple approach by using Sieve of Eratosthenes. And now the analysis. Using this algorithm, we can eliminate all the numbers which are not prime and those that are lesser than n. This is the our target, and we will traverse from 2 to the root of given number. This is the main point here. Why root of n? So what is the reason for traversing until under root n? There will not exist any factor of n greater than this one. This is the main property. No factor of a number exists up to n. Suppose x and y are the factors of n. In that case, if x and y are factors, then x cross y must equal to n, and hence at least one of the both should be less than or equal to under root n, so we need to traverse until this only. So need not to traverse whole the list again. So by using this property, we are getting the much better time complexity. Just take another example to better understanding. Print all the prime numbers less than 15. Just we have created a list. This is the first step. Up to start from 2 to n. N is 15 here. Now from 2 to root 15. What is the root 15? That is 4 point something. We can say that is 5. No problem. Means we choose here to there. Remove all multiples of 2 first, then the list will be remove or mark, remove or mark. If we are removing, then multiple of 2, that is 4, mark as 0, 6, 8, 10, 12, 14, mark as 0. If we delete it, list will be shrink. And then now number is 3, immediate non-zero number, immediate non-zero number available, that is 3, after 2, that is 3. Now mark all multiples of 3, all multiples of 3, that is 6, that is 9, that is 12, that is 15. Now number is 5, which is the next prime number, but not less than or equal to root 15, because root 15 is 4 point something and 5 is greater than root 15. So here stop the process, and our list contain the all the prime number up to 15. So prime numbers up to 15 are 2, 3, 5, 7, 11 and 13. So this is very simple process. Now this is the Python implementation, how to implement our concept of Sieve of Eratosthenes by using Python code. We will see here, just, or we can take another example, big example, to understand in better manner. We can use the list just for big number. One, we are generating the numbers by using Excel sheet. Here generate the number, here also. Minute. Copy the numbers and paste here. Okay. Now if we find prime numbers up to 80, so how to write it? These are the numbers. First cannot be, one cannot be a prime number, one cannot be a prime number. So one cannot be a prime number. Start from 2 to 80. Now choose the 2. Now choose the 2. Now choose the 2 and delete all multiples of 2 from the list. We are going to delete. We are going to delete. So 4 may not be there, 6 may not be there, 8 may not be there, 10 may not be there. All the multiples of 2, that are this one. No even number except 2 can be a prime number. So delete the prime number, delete the even number except 2, simply this one. Now next available number, that is 3. Now choose the 3. Next is 3. Now delete the multiples of 3, delete the multiples of 3. 6 is not in list, already deleted, 6 is already deleted. Now delete the 9, delete the 12, already deleted. Now delete the 15, then 18, 21, 24 already deleted, 27, 30, now that is 33, 36, 39, now 42, 45, 48 already deleted in the list, 51, 54, 57, 60, now 63, 66, 69, 72, 75, 78. So this is deleted factors are. Now under root of 80, this is approx up to 9. We must check up to 9. This is just something 8 point something. So we must not go beyond the 9, means up to 9. Only 5 remaining is 5 and 7. Only check for 5 and 7. Next available is 5. Now delete the multiples of 5. Now one point to be noted, that 5 square, what is the 5 square? 25. Before the 25, all the factor, all the multiples of this particular 5 are already deleted. 10 is already deleted, 10. 15 is already deleted, 20 is already deleted. Okay. So to improve the efficiency, not start deleting will be start from the square of a particular number up to n, up to last number. This will improve the efficiency, because before the square of this particular number which is selected, all the multiples are already deleted. So now delete 25, start from 25, 30, 35, now 40 already deleted, 45, 50 and 55 and 60, 65, 70, 75, 80 already deleted. Now choose the another number, that is available number, that is 7. Now start. From where to start? Deleting 7 square up to, from 7 square up to 80. Now 7 square, that is 49, deleted. Before 49, before square of this number, all the multiples of 7 are already deleted. Just see here, 14, 21, 28, 35, 42 already deleted. So unnecessary checking is not required. Start from the square of a particular number, 49, and then 56 already deleted, and then 64, 63 already deleted, 70 and 70, now 77. Okay, we must not go beyond the 8. So 8 is already deleted, 9 is already deleted. Now all the available number in the list are prime numbers. Now available numbers are now 13 and 17 and 19 and 23, and this is 29, this is 37, this is 43, 47, now this is 53 and 59, 61, and next availability is 67 and 71, 73 and 79. These are the prime number up to 80. So by using this approach, we can easily find the prime numbers up to a given number. We can see here one drawback is here for this number, we must save all the numbers from starting. So this can take some extra storage. also. This point to, so if we want to find up to n, so n storage must be required to keep the numbers. This can be improved by using the concept all the even number except 2 are not prime numbers. So we don't keep the even numbers except 2 in the list first time. So this will reduce our space by n by 2 and then start the computation. So by using this we can find. Now the part as implementation part in Python. So this concept is implemented in Python by using this particular code. We can run this particular code in Python also, but first understand here we are going to define our function by using def keyword, Sieve of Eratosthenes, and we pass a number, that is the last limit up to from 2 to this particular number we are going to generate the prime numbers. Now the prime, this is the list of prime. We are making the prime number this funda to generate the list by using the concept of list comprehension. This is the list comprehension technique to generate the list. Just guess, if the num is, just in the previous case num is 10, so this will generate the 10, I in range 0 to 10. Just see here. This will generate a list 0 to 10 and make it as true value 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, only 10, not this part. Okay, no problem. Only choose up to 10 and make it true, make it all the values true first time. True. And for I in range, 2 to start from 2, I in range start from 2 to, this is the root of n, num power, this is the power sign, num power 0.5, that is the root, and we are converting it by using int. So just root 10, that will 3 point something, and int we are converting it to the int, so this will give the 3 here, 3 plus 1 means this will 4. Now excluding 4 means that is 3. So this loop will select the value 2 and 3 only, 2 and 3 only, 2 times this will loop will. So first now the I value is 2, this is the value of I is 2, number up to a square root of a number, this is comment. If prime I equal to, if prime I means value at this particular selected location is true, means t, then what we are doing, we are making it its multiple as false, its multiple as false by using this inner loop, that is j. Now j in range, from we are selecting the concept I square, starting from the I square, as we have discussed in the previous slides, I square up to the last of the list, and increment value is I means the we are choosing the multiples, so increment by that particular number I. Now I is 2, so multiples of this starting from its square, that is 2 square is 4, starting from this location, and make it as a false, make it as a false. Multi increment by I is 2, so 4 plus 2 equals 6, make it as a false. Now 8 make it as a false. Now this make it as a false up to last. Now take the next number from the outer loop, the means the value of I, now the value of I is 3. Now choose the 3 and check if the value at the location index number 3 is true. Now 3 is true, yes, this is true. So inner loop will be executed, inner loop is executed and delete, make the multiples of 3 is as false starting from its square. 3 square is 9, go to the 9th location, its value is true, yes, this is true, make it as a false, make it as a false, yes, make it as a false up to no next multiple available. So exit from the inner loop and outer loop, only 2 and 3 are chosen, yes, come outside the loop, come outside the loop. Now print all prime numbers, print all prime numbers which have the true value, start from 2 goes up to the last, start from 2, not from here, this is for our convention. So start from here, all the true value, this is true, so this is a prime number, this is true, so this is a prime number, this is true, so this is a prime number, this is true, so this is a prime number, no values are true, all are false. So prime numbers up to 10 are 2, 3, 5 and 7. This is generated by using Python code. Okay, this is the dry run, we can execute the code also using its editor and interpreter also. This is the driver code, as we say, if first time we choose the 20 and then call the sieve of Eratosthenes by the for this number 20 and generate in the same manner as we have chosen for 10, here for 20 all the prime numbers 2, 3, 5, 7, 11, 13, 17 and 19. So implementation in Python is very effective and the efficiency here is n log of n. This is very much effective algorithm, and space efficiency can also be improved by using n by 2, remove the not selecting the even numbers except 2 only. So okay, thanks a lot.